So this session is builds on the previous session. So in the previous session we saw how to create a suite definition with a basic content, suite families and tasks, and now we're going to start looking at advanced topics. And by advanced, I'm going to mention and maybe correct the slide there. It's just slightly more advanced ecFlow topics. These are topics that, in fact, we actually use in our daily operation. They are not simple, but they are not transcendent anyways. And most of these ecFlow topics that we're going to discuss relate to specific attributes. We haven't seen, apart from variables, which I mentioned in labels, meters, and events, we haven't seen anything else, at least in great detail. Let's do that now. So the topics for this session, as I mentioned, I'll give you an overview of the node attributes. There's plenty, and there's quite a lot of them that we won't mention here. We will mention variables again. I'll discuss them a little bit further. I'll also discuss attributes related to task progress, and I'll show you some use cases for them. And I guess most of the time we'll actually be looking at dependencies and the several kinds of dependencies. Remember, all of these are just attributes, right? We're talking about one text line in the definition file, at least in terms of implementation. So these dependencies, I guess, will be the most part of the discussion today. And triggers especially will be quite interesting, because these dependencies are the ones that transform the tree of nodes into an actual graph, right? They make sure that the dependencies are the ones that actually make task 2 depend on task 1. Only when task 1 is done, it allows or triggers task 2, right? That's where the name actually comes. But not only we'll be looking at triggers, and there's quite a lot to say there. We'll be looking at the completes and then temporal dependencies. So these are triggers not between tasks, but tasks in relation to actually time, right? The time constraint. We'll close the session by talking repeats, and I'll explain what they are. But basically, they allow us to iterate over. Will allow us to automatically repeat our suites and families. And finally, I'll talk about limits and the combination of attribute limit and attribute in limit. I think some of them, I think limit already mentioned by Ian in the first session. So let's talk about what are attributes. Attributes, well, implementation is one line in the definition file, but they are much more than that, right? Attributes are a component of that tree that you'll see in the UI, and they add a characteristic, add something to the node. They make the node behave in a certain way, right? Depending on the kind of attribute. They either add a characteristic that did not exist before, or they configure the node to do something in a special way, right? Or store information or something, right? So as the bullets are there, they are able to customize. They are used to customize task script behavior, right? So you put something in the suite definition so that it actually has impact on the task and eventually the job that is going to run. They define the initialization behavior. They are there just sometimes for the operator that actually spends the day looking at the UI, actually to see information there, because it is useful for them to see if something is happening or not. Okay, they of course describe dependencies between nodes. They enable looping behavior, or even some cleanup of the nodes. It can be done automatically or dynamically. I'm not even going to talk about process control, but maybe I will. So if you look At this table provides you kind of a hint of what the attributes are used for. There's looping, scheduling, control, information used in task script, initialization. There's all of them. We're gonna mention not even half of them, I believe. But the documentation has information about all of them. Some of them are a bit more important, or not important, they're all important, but they're more used or more useful on a daily basis, and those are the ones that we're going to discuss here. Okay? Some of them are quite new. For example, I'm looking at Aviso and Mirror that was implemented recently. But most of them are quite established, right? I didn't want to mention process control, but I will. If you look at the process control, there's only one attribute, which is a zombie. A zombie isn't an attribute that you can actually specify. It's an attribute that is attached to the node when something goes funny. And by funny, I mean if you try to rerun the task twice, and in fact you submit a job, and then you submit and you rerun it and submit another job, there are two tasks submitted and running, each of them potentially with its own password, so its own identifier. But for the server, there's only one, the last one you actually executed. When two of them start coming back and saying, oh, I've done this, I've done that, and they're starting to communicate to the server will say, sorry, I only know this one. Who is this other zombie that is talking to me? And that's where the name comes from. So zombie is not even an attribute that you can specify. It's something that happens because and it helps us manage the execution of the tasks. Okay? So some of them, it's not something that is useful in the sense that I want to use this feature. It's something that you need to because, for example, in this case, you have multiple tasks running in parallel when you should have only one, right? But let's talk about for me my favorite of the attributes, which is the variable. A variable is, of course, a node attribute. You can put variables anywhere, including at the server node. So when you launch the server, you can say, oh, this server has these variables, and even if you don't have anything any suite loaded, you can still click on the server node, and you'll see on the UI, you will see some variables there, and those are server level variables. Okay, typically they associate a name with a string value, as we've seen, and basically we call them edits in the suite definition, right? So you say edit, then the name of the variable, and then a value. I put the single quotes there, but they don't have to have single quotes. Okay? And we call them edits because they are used to, air quotes here, we're going to edit the task script. That's one of the functionalities that they have, is that they allow us to put values into the task scripts, right? And we'll see in our example, in the tool that we're going to do afterwards, that how we can actually change the amount of time that the task takes by changing the variable. So we don't change the task script, but we do have impact on the way what actually is being done, right? At the task level, at the task script level, you can ask the preprocessing engine to say, oh, replace this between the percentage signs, replace me this variable, or if you provide colon and the default value, right? So that's what I mean here. If you use something like sleep :5, means that if there is a sleep variable in the suite definition, then that will be the value that is being actually copy pasted into the job, right? Otherwise, if it doesn't exist, you can use 5. So the preprocessing engine would just say, okay, I'm going to leave this as 5. The variables, they're not only to put things into the task script, but they can also be used in triggers and expressions, with a caveat that they need to be converted to integers at that point. So the trigger expression engine, the one that actually evaluates the expression, will try to convert the value of a variable to an integer. In practice, there are three kinds of variables. There are variables that are system or environment variables, and these are used basically to configure ecFlow itself. Things like the ecf home, the ecf job command, all of that that influences the behavior of ecFlow itself. Okay. Then there are generated variables. Basically, these are generated by ecFlow based on the environment, on the setup, and these are generated so that the tasks can use. For example, ecf name, so that it can be used as the path inside the task scripts. Also ecf port. There's ecf password is also generated so that the task then knows how to actually come back. And of course, apart from the system and generated, you have user variables, the ones that each of us will use to actually customize our task behavior. Okay. It's important to understand that the variables are inherited, and meaning you can have at several levels in your suite definition. You can have variables, and you can have repeated values for the same variable. This has some impact, of course, but basically we have an inheritance and an override system here in place. The variable that is used for a task is the one that is closest from the parent node. Okay, and there's an algorithm here. I don't want to go through it. I think it's easier to actually understand it with an example. And I'm going to focus here on the task T1, which is, so for this suite definition, we have this UI view. And for task T1, if I want variable A, the algorithm says, is A defined for T1? No. Is it A defined for the level above T1? No. Is it defined yet another level? Yes, it is. It's defined as A. So this is the A value that we're going to take. Okay. If we do the same thing for B, we start by looking at the node itself. We don't find it. We go one level up, and we find B equals 20. So B is 20. Even if there's a B equals 10 here, we don't look at it. We only look at B20. Okay? And if we do for variable C, A is defined here, attached to T1, so we don't even look further. So we don't care about anything that is defined above. Okay? And the same for all other nodes. So and this algorithm takes place for every time that the variable that a task script is created. All the variables are searched using this algorithm. So it's important. This allows us. This has the benefit that if you want to have a set of defaults, you can put them on your suite level, and then each of the families can be customized in its own way, right? You can leverage on this algorithm to customize the behavior of your tasks. Okay? And we'll see that in the examples. Basically, the suite level will have a sleep of 20, and then each of the families can have a sleep of 5 or 10, and basically, depending on which family you're in, the task will behave differently. Okay. Apart from variables, my second favorite, all of them are favorite, but these are just slightly less favorite than variables, are the event meters and labels. And event meters and labels are attributes that basically attach themselves to the task and provide information about progress, typically progress. Events typically signal a task achievement. Imagine that you have 3 stages in one of the tasks. What you do is you create 3 events, and every time you reach event A, B, or C, or goal 1, 2, or 3, you go and set it to say, yeah, I've done this, I've done that, and I've done the other one. Okay, and it signals other tasks that only depend on goal A, B, or C to actually, okay, A is already done, so I can start processing. Okay, that's basically the use case. The meter is a proportional progress. So, oh, I'm done at 50% or 20%, or I have to process 1,000 files where I only process the first 100 or 150 or 151, 152. So it's a proportional progress meter. And label is a free-for-all. You can put anything in it. You won't be able to use it in triggers or anything like the other two, but you can definitely put information there. So you can, if you set up a string that tells you about progress, that's what you'll do, but you can do all sorts of information. It's just a label, as the name implies. In the suite definition, as I mentioned, it's just a line, event name, and then it's either set or clear. By default is clear. You can specify a meter with a lower bound, upper bound, and the color change. This is a mere visual effect. Color changes, if you put 0 to 100% and you're satisfied at 80, you can put color change at 80, and the bar actually changes color after the 80. But it's just a visual cue there. And then label is just a label. How the task, we've seen this. So the task commands in the task script, you can call client ecFlow client event name to set it or clear. The same thing for a meter. You can dash meter, the name of the meter, as you can have multiple names in one node. You go and set it to a new value, or you can just change the label. So the commands as they are here in the form of task commands will update the label, meter, or event attached to the node where this command is being called. Okay. But a task can also change the meter of some other task, right? And for that, the task itself has to call a user command, something like this: ecFlow client -- alter. That's the command, and the command is to change a label, event, or meter, and then you gave it the name and the value that you want to change to, and you actually have to say, oh, and this is the task with the meter that I mentioned that I want to change. It is possible. It's not very common to have tasks that actually change someone else's events or meters. Okay. So the first variables, labels, meters, events are more funny, but we come to dependencies. And dependencies are a big, have a strong importance in ecFlow as they define the graph of tasks. The dependencies can be triggers, basically specifying this task depends on another in a certain way. They can have temporal dependencies. The task that only runs at a certain time of the day, or a certain day of the week, or on a certain day, the first of every month. Okay. Or there is also a limit dependence in the sense, oh, I can only use one CPU, so I can only run one task at a time. Okay. These are all dependencies. These form a graph. Not all graphs are linear, for example. The limit, for example, doesn't impose that the task A runs after task B. Okay, it just says from A and B, only one can be running. Right? So that's something that you need to consider. Even though the position inside the suite definition actually implies the order they are run. But limit per se doesn't do that. It's also noted that a node can have multiple dependencies of the same kind. It can be a node that only runs on one CPU of the two available and only runs after task X and only runs on the first of the month. Okay, so you can definitely consider multiple dependencies there. A bit of terminology. It's a dependency is either holding, that's a name that we use, holding in the sense of not allowing, holding back the task from executing, so not allowing it to execute. The counterpart is, and we don't have a name for it, it's either expired in the sense of the time dependency has expired, so it's now okay. It was to run at 12. It's now 12:01. We can run it. It has expired, or it is released in the sense of the trigger. It was released, and the task can be executed. Only when all dependencies are released is a node actually allowed to execute. That's important, right? It's not just, oh, I have the CPU available. No, it said I have the CPU available. It is past 12, and it's the first of the month, right? You have all of the dependencies have to be released or expired or okay to be for the task to actually run. Looking a bit closer to the first kind, triggers. Each node has what we call a trigger expression. And the trigger expression can be as complex as necessary. And some of them, well, Axel will show you some, but I'm going to say they are pages long. They can be pages long, even though in the ecFlow UI, you only see a smidge of the expression. You can definitely click on the tab to actually see or the full expression and see how complicated it is. The trigger expression is a Boolean expression, so in the end it has to evaluate to true or false. You can't just say 42, that doesn't count. It has to evaluate to Boolean, to true or false. And if it's false, it's set to be holding. When it's true, it's set to be expired or released. Okay, so if when I build my expression, I want it to evaluate to true when I want to run. Okay, so that's the idea. The main idea here is to have triggers on tasks or families, and they should be avoided on suites, because a suite, if you put a trigger on a suite, it cannot really depend on something that is inside that suite, because if the suite is holding, nothing else below it will run, so the thing will be blocked forever. So if you have a trigger on a suite, implies that it mentions other suites on the same server, and that goes a bit against the design of the trigger, right? The trigger should be something. So suites in themselves should be self-contained, shouldn't have references to other things outside of the suites. That's why they should be avoided on suites, but they are valid, and ecFlow will look at them while trying to evaluate them. I mentioned the ecFlow UI, and in the info panel, you'll definitely see a tab called Why, and you will see why is the task not running. That's why. That's why we have the why. It's why is this not running? And you see here, basically in this case, task T4 is queued because it has an expression. In this case, it means a trigger expression where the task T2, which is active, is expected to be complete. And because active is different from complete, the expression is false, and the task 4 is queued, so it's holding. You also have on the same panel, info panel, you have a tab triggers, and triggers do allow to have the expression in this case, and even in a graph shape. And there are huge graphs that you can see, and this is where actually the graph that explains what the dependencies are, right? In this case, it depends, T4 depends on T2, but it also depends on and this is an event on T2 and a date. Okay, so it's all there. As I mentioned, trigger expressions are Boolean, and they can be composed of all of these operators. I'm not going to go through them, but as you would expect, these are Boolean operators. But we also have arithmetic operators, so you can have a date, add another 3 days to it, and that you'll be able to use it as an integer to have a trigger expression. Okay. You can use variables and you can use parentheses. One thing that you can use are expression functions, at least, for example, these two expression functions that allow you to convert a date to Julian date. So it would be a continuous integer to name a day, or from Julian to date. It's also possible to convert. I put a note here because Axel will show you quite complex expressions. Please don't be afraid. Axel is a super user. He knows what he's doing. Most of the times the expressions aren't that complicated, but he will show you some mitigation actions for those as well. As I've mentioned, there's some graphs that actually some graph dependencies tend to be quite big. I'm just going to give you a few examples, but nothing as complicated as this. For example, you can depend on node status, basically on a path to a node to be complete. So this node could be either a task or a family. The paths could be relative. You can depend on node events. So you put a path and then the name of the event. If goal A, B, or C has been achieved, you can have variable dependencies. You want the date, and this is a generated variable, to be larger than the 1st of January 2025. You can use the expression functions as I mentioned, and of course you can combine them with and or operators with parentheses. Okay. There are dragons, well, at least deadlocks, to consider when you're doing graphs. And I have here 2 examples. You have example, I'm going to call it a event circular dependency. Basically, you have 2 tasks, T1 and T2, each one of them with an event. Okay. Eventually, they will set these events when they start running, but T1 depends on the event of T2, and T2 depends on the event of T1. So this is circular. No one will ever be able to set its event because it's waiting on the other one to set its event. So they are in deadlock. Okay, this will never be reached anywhere. Okay, and the same thing here with node status, where task T1 depends on task T2 to be complete. Task T2 depends on T3, and T3 on T1. So everyone is waiting in a circular dependency, and that means that no one will run. The good thing is that we have a Dragon Slayer among us, and that's the Python API, which has the capability of simulate all of these things with the expressions, and will detect deadlock for us. So if you're using profusely trigger expressions, I would suggest you to get acquainted with defs.simulate because it definitely helps to avoid these kinds of things. And these examples I put here are quite simple, but if you have several families with events and triggers and dates and all of it, it's quite easy to get in a deadlock that you don't even understand where it's coming from. These things tend to be quite complicated. What we've been talking until now are triggers, and triggers, I mean, included triggers that go in, that are defined in the suite definition. There are other kinds of triggers which are, and these tend to be called embedded triggers, meaning that they are embedded in the task script. And that means that the task starts running. At the end, does, I don't know, 2 or 3 steps of what it has to do, and all of a sudden calls this command. ecFlow client waits, and on an expression, just like the ones we were looking before, but it's an expression, and the task will basically, this will make the task wait. So this will freeze the task until that expression is true. Okay. While it's not true, this task will never continue to run from that. It will be hanging or holding on that expression. Okay. Basically, this implies that the client has to contact to see, is it true already? Is it true already? But there's like a communication between client and server in that scope. Okay. The embedded triggers have pros and cons. One of the pros is that you can construct the expression at runtime. So the task itself can say, oh, am I holding on the event of A or on the event of B? Or you can basically manipulate the expression at runtime. One of the cons is that it's not only validated at runtime, while the ones that you put in your definition file, they are evaluated as soon as you load the suite. Okay, if there's something wrong, a parenthesis that's made, the load will fail. This one, it won't, right? Only when it's submitted to the server, the server look at the expression. Right? So there's kind of pros and cons. I think the guideline is whenever possible, try in-suite definition triggers. In combining triggers with completes, and complete is the attribute that we want to talk about next, is adds more, right? So we don't always want a task to be triggered to run. Sometimes we want to be triggered, but only run in some circumstances. Okay. And that's why completes are important. So usually triggers and completes are used in sequence, in the same node, right? You have a trigger expression and a complete expression. And basically the complete expression allows to bypass the execution of the task, right? Here. Basically, the trigger says, okay, I can now start. And the complete says, I really don't want to start because I don't have this information. I'm not going to do it. I'm going to complete myself without actually running. Okay. Grammatically, they are identical to triggers. And in practice, they are always used in combination. I'd like to show you here the example. For example, the complete, which is the pink. I hope no one here is colorblind because, yeah. So the first one, the first expression here is the trigger. This means that the task T4 will only run after T2 being complete. Okay? Meaning T2 will run to the end before T4 even has the chance to run. But will T4 run? Well, it depends. It depends on the complete expression, which is the one in the bottom. And as the orange arrow shows here, it only runs if the event in this tick here, this square here, is a clear event. It's unticked. Event O2 is set. So meaning it's unset. If T2 ticks these 2 boxes, and by the time that T4 is going to run, this is ticked, yeah, it automatically completes. Because, I don't know, T4 was supposed to be an alternative way to compute O2, and the O2 is already computed, so we go and give up. Okay, we don't want to do it anymore. and T4 doesn't even run. It's not submitted at all. Temporal dependencies are the next kind of dependencies that we want. We have multiple ways of defining time dependencies. Of course, time dependencies, a day dependencies is day of week, dates or today's, which are similar to time, which is a specific time of day, like hour, minute. Today is the similar to time, but with the fact that with a difference that immediately expires, so it lets the task run as soon if that time of the day has gone past this day. So imagine it's 12, you requeue a task at 12. If it has a today of 10, it will immediately run. Okay, because it's 12, 10 has gone by, it's going to run. If the today is 2 o'clock in the afternoon, then it will hold until 2 o'clock in the afternoon to run the task, right? This, if you do the same thing with time and you set it at 10, what time will do? It will wait until 10 the next day to actually run. Right? That's the difference between today and time. And then cron is like the cron on Linux or Unix systems that actually repeat the task every time. So it does it at a certain date, time, minutes, and then once the task completes, it actually goes and repeats it, requeues it for the next execution. So it allows cyclic re-executions. It's important to note that when evaluating temporal dependencies on the same node, dependencies of the same type are ORed and of different times are ANDed. This has practical implications. For example, this means this task T is going to run on day 1 or 2 if it's either a Sunday or a Saturday, if it's either 0 or 12 or 12, right? So it might be one of them, one of the dates, one of the days, one of the times, and any combination of one of them will work, but you have to have one of each at least, okay? This works on the same node, but does not work the same way on different nodes. And basically, there is there is a cumulative time constraint on each level, right? And this doesn't always work as you expect. I'm going to give you an example which caused me a bit of a surprise. If you have family F, which has a time 10, and then a task T that runs only on Mondays, and you run it on the Sunday, you requeue it on the Sunday. What happens is that on a Sunday at 10 in the morning, this time will expire. So it says, okay, anything in family F can now run. And but the task T isn't Monday, so task T is not going to run, at least until it's Monday at 0 o'clock. At 0 o'clock, right? And that means it will run at 0 o'clock, which means that it won't run at 10, but it will run at 0. The first second of Monday, this task will run. It will eventually finish, and if it's requeued, it will run again on Monday at 10 as expected. But no one would expect it to run, at least I wouldn't, naive me, I would not expect it to run on Monday at 0. Right? It's because the family says it's supposed to be running at 10. So these things, especially if they're not in the same node, they're definitely going to be playing with each other, okay? So you have to be careful there. I only have repeats and limits to go, so we're almost finished. I'll ask you. I'll answer the questions from Milena afterwards. So repeats basically allow you to iterate over a sequence of values. And there are multiple values or multiple sequences that you can define. Basically, a range of integers. You specify the first, the last, and the step that you want to go through. You can just enumerate the values that you want to, and the values may not be numerical values. They can be a list of strings, for example, a list of colors if you want. You can have a range of dates. So beginning of January until the second the 2nd of February, every 5 days. You can specify something like that, or just a list of date times or a list of dates. So you say the 1st of January, the 2nd of April, the 10th of August, and it's fine. It's just a list of dates, and then there's a day step for sweets. We're not going to talk about it. The thing with repeats is that it will repeat everything that's underneath it, and when everything is completed, it will basically automatically requeue everything with the new value. Talking about value, how does the task know that I'm running on the 1st of January and then the 2nd of January and the 3rd of January if it's a range of dates? Well, they are generated. These values become generated variables. Okay, depending on the repeat type, there will be a set of generated values. For example, here, if I create a repeat for family F, a repeat that is a date, and I call it YMD, because that's a name that we like to use at the center. And you say from the 1st of January to the 31st of January every day. This YMD gets generated as variables as YMD for the actual full date, but you also get an underscore DD just for the day, underscore day a week, DOW for the day of the week, a Julian day, a month, and a year. So all of these get generated, and these can be used with in between percentage signs, and they will become part of your task. Right? So that's how all of this mechanism allows the task to iterate over values, right? And it really depends on what you can do. And if it's 20, it's 20. If it's 10, it's 10. It will go through this, and for each iteration, when everything is complete, it will just automatically requeue. Okay? It would be up to the task in that case to actually generate different outputs. For example, if it generates always the output A, by the time you get to the end, you only have one output, which is A, for the last iteration. Right? So it's up to the task to make sure that the outputs are not overridden, right? Here are some examples, but we are getting a bit late, so I'm gonna skip to the next one. There you go. And the last one I want to talk is limits. And there's two attributes that play a role in limits. Is the limit, which actually says, I am a counter, I am the limit. And the limit is 50 megabytes on the disk, or gigabytes or something, right? And that's the limit, or 30 CPUs, right? I only can have 30 CPUs for that, okay? And that basically establishes the counter that will be used, and typically is defined at the highest level possible, or in a special family that only contains limits, or only contains these counters. And then the in limit actually imposes the limit. The in limit is the thing that you actually attach to the family, or to the family, or to a task, to actually impose a limit of this task only runs when that counter allows it. And I have here two examples. This one here is we have a very weak node. It only has 2 CPUs. Okay, only has 2 CPUs, and this is defined at suite level. And in this family, everything is in limit CPU by default is 1, so it doesn't show it. But meaning that only 2 tasks will run will ever run from this set at any given time. So in this family, which is in limit CPU, only 2 tasks will be able to run. Okay. If the CPU were 5 and in limit 2, meaning that each task would use 2 CPUs, and then you'd have to see how it went. Okay. The same thing here for disk space. This disk only allows 50 gigabytes or something, I don't know. And then each task has some in limits. So the task 1 needs 20, task 2 needs 20, task 3 needs 12, and 12, 20, and 20, if my math doesn't fail me, is more than 50. So this one isn't allowed, T3 isn't allowed, but T4 is allowed because we have 45, and even T5 is allowed because that's 50. So this task here, T3, was jumped, was basically left holding. The limit is holding it back from running so that we can run things with this space we have. Okay, so these are the more advanced features that I wanted to show you today. And I think we can go to the practical session. The practical session is, as before, just one section of the tutorial that is online. Make sure that you go to all of the subsections. So each section. So the first one will add a new family. The second will add a new label, and then a meter, and then a trigger, and the trigger with the complete, and then embedded triggers, and all of that. And you can go through all of them. And well, I'm here to help. Hope you enjoyed it. Thank you.